Hello everyone, welcome back to the day 20 of Advent of Cyber 2024 of TryHackMe. So we are today with the day 20, which is about traffic analysis. One of my favorite of analyzing traffics in my blue teaming or in my malware analysis thoughts. So without any further ado, let's just continue today with the story and concepts to learn. Diving in, day 20. If you utter as much as one packet, what is going to happen? The story. The glitch snuck through the shadows, swift as the breeze. He captured the traffic with a delicate ease. A PCAP file from a system gone bad, Maya malware trick made everything mad. So today we are analyzing some traffic. So they have given us a small poem regarding it. And now let's look at the story of today. Mixed Kitty at her desk, staring at the PCAP file Glitch had sent over. It was from Marta May Ware's computer, the latest victim of Maya Malware's long-running schemes. She smiled, glanced at Byte. Looks like I have to use Wireshark again. Hey boy. Glitch's voice cracked over the comms. Need any help analyzing it? Mixed Kitty smiled. Thanks, Glitch, but I've got this. So today's learning objectives is to investigate network traffic using Wireshark, identify indicators of compromise IOCs in a captured network traffic, then to understand how a C2 server operates and communicates with the compromised system. Now for the machines I've already powered on, it's in the other tab here. So that I don't waste any time if it takes too much time to load up. Okay, so before we continue with investigating in depth, there's a small poem which they've given us to understand of today's theme. Mixed Kitty peered at the PCAP with care. What secrets, she wondered, are hiding in there? With Wireshark, she will dig through each byte, hoping to shed some much needed light. I guess Mayor is in very big trouble today because we got a PCAP file which we can investigate. Now, before we get into investigating the PCAP files, let's understand the scenario here. So, what has happened is we have a compromised system of Marta May, and the network traffic is going to show us some communication between her computer and another server. And what is that server? That server is a command and control or a C2 server in short, which is nothing but a server which is going to tell the malware or the infected malicious program which is saved in her computer an instruction to do what after her computer is compromised and it has got some initial access and all. So the C2 server behaves as a master behind controlling all these malwares and the viruses which are sent or deployed to the victim's computer. It's going to have a communication from the victim's computer. The victim computer is going to share all the details of the computer related to the usernames or the uptime of the computer, the network speed, the network traffic which is going on, how is that, and all those things, all those information to the C2 server. And whenever the C2 server, depending upon the attacker's wills and wishes, whenever it is programmed to tell the malware to deploy some more malwares or some more infection to the computer, it's going to do it. It's like if it wants to go and what compromise other computers which is there in the network, it can do that. And all those things, instructions. Basically, it's the one which commands the malware or the payload to do what in that system. So that's the C2 server which they've told us here. And usually the communication between a C2 server and the victim's computer is going to be happening not on a regular intervals, but there's going to be a ping kind of a request which is going to be sent from the victim's computer to the C2 server saying that the computer is online or that malware is executing all fine. So that ping request is called as a beacon. So beacon is something where on a regular or an irregular interval, it's going to be sending a request back to the C2 server saying that, yes, I'm alive. I'm ready for your operations to come ahead. So something like that. It's going to be giving confirmation for the C2 server, telling that it's alive and it can be, it is ready for initializing any payloads or initializing any attacks whenever the C2 server wants it. So they've given a somewhere down below they have given how that communication would look like. I guess it's somewhere here. Okay, I'm not able to see it here, but yeah, you can see it as we scroll down the page. So, what are we looking for this room is analyzing Wireshark traffics to look at the communication that happens back and forth between the victim's computer and the C2 server, where we'll be analyzing all the different types of traffics which are going between the computers. So, diving deeper, now that we have a better idea of what C2's traffic looks like and how to use Wireshark, let's get into analyzing it. Okay, so they've got the IP address. So let me just copy the IP address and I'll tell you why in a moment. So let's come back to the machine here, our Windows machine, and we have a C2 traffic analysis PCAP file. PCAP file is nothing but a network traffic file specifically for tools like Wireshark and TCP dump and all those tools which has the ability to read a packet files. Okay, so let's give it some time to load and run the Wireshark tool. So this is how a Wireshark would actually look like. In a better view, we would look. It would be a dark theme. Let's see if I can have a dark theme. This is all out of scope. I'm just doing it for my fun here. Let's go to settings. This is not probably going to be there, but why not just look at or give it a try, you know? So colors. How do we change the theme? Or dark, yeah, click on dark. Oh, that's good. So now, yeah, I've got a dark theme of what do I say? The packet analyzing Wireshark tool. Okay, fine. There's no other way to do it other than to set the computer's default theme to be dark theme. If not, Wireshark does not change its theme, or there might be, I don't know. Whenever I saw it recently, it was that's the way how we do it. Okay, so what here we can see is the one request or one packet. Let's just take an example of it and then analyze it. Then further go into analyzing the today's room. So here is the number of serial numbers, the packets in order when it was sent, and the timing when the packets were transferred back and forth, the speed and all those things. Now the source is from where the packet was initiated. For example, let's take have a computer here. So if this computer sent a request, that's going to be the source address. So this is talking to another Google server. Let's take for as an example. The destination is going to be of this Google's server, and then the protocol which was used. If I'm using a web browser, it's going to be HTTPS or some post or get methods related to it. So that's going to be the protocol. Most probably it's going to be UDP or HTTPS or TCP communication that happens between my computer and the Google server for whatever reason they are communicating. It again depends on what services or programs that you're using. If I'm doing a file share, it's going to be FTP or SMB or those things. Those are the protocols there. And then comes the length. The length is the number of contents or number of bytes which is being shared back and forth. That's going to be containing the length. And then information, what exactly it is doing. So for an example, let's take this one. It says acknowledgement. Okay, this is a TCP communication. So what is happening from what port number to what port number is communicating? So you can see 51509 and then 3389. That is the port number that is communicating between each other. And an acknowledgement packet is being sent with the sequence and all those things there. So that's the pretty much basic information regarding what exactly is happening there. Then in the down left side of the screen, you can see some more information when you click on that drop down box. Here you can see the arrival time when it was the more information regarding the packet which was transferred back and forth, and then the Ethernet IT, all those MAC addresses and the destination addresses. It's all can be seen here. The source is MAC address. Those levels of the OSI model, the 7 layers of OSI model, they're going to be broken down here. The physical, the network, and all those things which is there. Those things will be broken down, but not exactly the OSI model. But yeah, those pretty much those information are going to be here. And other details regarding what the file was containing and all those things will be here in the two formats. One is the hexadecimal format, the most popular way of looking at any traffics or data, and the other one is going to be the decrypted version of the hexadecimal character, whatever we see. So with that understanding, let's do some analysis now. Now I have copied the IP address from this browser here, which is going to be the Mata Maya's IP address. So what we can do is, now here I have a lot of other traffics also going on. The thing is, with Wireshark, whenever it's capturing traffic, it's going to capture all the traffic depending on the interface that you have chosen. If it is doing a communication with another web browser or all those things, channels and all, it's going to still capture that. It's going to capture everything that is going back and forth in the network. So we want to filter the only ones which we want. For that, what we'll use is the filters which we can type in here. Now, since I only want from Mata Maya's IP address or her computer, I'll be selecting IP dot address. Then I'm going to say source. That's what is the command. No, IP dot source. Let's do that. So I'll say IP dot source. So src and then equal to the IP address which I copied, which did not get copied. So let's copy it here and then paste it, then paste it here. Okay, so I'm going to put that filter and then press enter. Now you can see all the source addresses are going to be of 10.10.229.217. So all the IP address of source is that itself. And the destination here, we can see it's all the same destination, which means that this computer was only talking to one server in specific. And here we can see the protocols which are being used, the TCP protocols and TLS and all those things, and the length of it. So what was the information that was being transferred back and forth, and then the information regarding it. So looking at the data here, we can see some acknowledgement packets being transferred back and forth, and the application data, some information is being transferred. So as you get more and more details, you can get a pretty much good understanding about the effectiveness of this tool. So scrolling down, somewhere down here, we can see other information regarding the tool, which will be quite useful for our analysis today. So all of these are just the back and forth communication that is happening. Then application data. Let's look for something which is unusual than application data and some acknowledgement packets. Okay, let's go down. So scrolling down, we see some web application of synchronization happening here. So this is the process of synchronizing with the server. It's using a TCP communication to port 8080, and from our source port is 51404, and the destination port is 8080. So we have some different kind of communication here, and down we see a HTTP communication having a post method. So post method is the method in web applications to send some data to the server. So that's what is happening here. It's the length of 8068, and it says application initial. Yeah, it's provided right itself. So it's explaining that, and it's on the text which is plain because it's using HTTP communication. And here this is the hexadecimal characters, and this is the clear text. So I can see some part of the clear text which says I am in Maya, right? So that information is present here. Now to look more in detailed version of this, what we will do is let's just click on this. What happened to my cursor? Okay, and then click on follow, and then HTTP stream. So that's going to give the complete flow of how that tool was communicating between the computer and the beacon and the server here, the C2 server. So here it says I am in Mayor, and then that is the post or the information that the computer is sending, and the response what it gets is HTTP 200. Okay, it says perfect. Okay, it's going to be confirming that yes, I got your message. So that's the information here given. So let's close that, and let's go back to looking at the other filters. So do we see it here itself, or No, let's go back to that stream itself. So ip.src. So IP, the same filter what we had. I'll just paste it in here, and then yeah, okay. So we saw initial post method, and then scrolling down, we can see another get method which says command in it, right? So let's also follow that TCP stream and look at what exactly it is doing. So here we see get command and nothing much here. It just says who am I. So who am I is like a command which is used after we compromise the system to look at what information is there, what is the username, what is the other related information. That's just an initial reconnaissance that as an attacker I would run. Or even if there's a malware and there is some staging required, some staging for the payloads with the usernames and things like that, that malware can also run these commands called as who am I. So this is a command which was run. Okay, we see that. Now let's go back. I know there's a better way to keep those flows of stream, but it'll be too much for this video for me to showcase all those things. So ip.source, let's do the typical way, the way how it is described in the TryHackMe's page. So coming back, we see that then also scrolling down the traffic, we see some finish stuff happening, the communication there. Then also another post, let's just close that. We see another post method which is being used to the exfiltrate section of the code or that web application. So then let's again follow the HTTP stream, and in here we see some content. So it says post all these things and some encrypted details, I guess. Right, so we get the key here, the file name, wait, the content disposition format data is file name is credentials.txt, the content type is application and octet stream. Then AESECB is your chance to decrypt the encrypted beacon with the key. So this is the key here. This is some, okay, it's a random text which we need to use for decrypting this encrypted character. Okay, so that's like sending some beacon is sending that information. So I described, right, beacon can also, once it says it's alive, it can also send some data in an encrypted format to the C2C server. So that's what is happening here. Let's try decrypting it. So let's copy this, then come back to the browser here, and then I'll open up a popular tool for doing all these decryption and encryption process using the web application using CyberChef. So I'll paste in the key which I copied from there, and then let me search for an operation. The operation is given here, AES. So AES decrypt. So let's put that in here, and then the key is given here. So let's copy the key and then paste it right here. Remove all those white spaces in between. Then the mod is it is ECB. So let's select that to ECB. Input is raw. Output is raw itself. Do I need to enter something here? Let's see. So then what else do we need? The decrypted key is given, the mode is given. Okay. Invalid length. I don't know what is the length here. Okay, UTF-8. And then ECB. No, okay. What does that mean then? So let's go here and see this. Where is that? Okay, so operations, yeah, recipe area, then the recipe where you would select the mode of encryption to be ECB, and enter the decryption key you have. Keep the other options as they are, and enter the decryption key you want to have. Okay, we did that, right? We entered the key and then selected the mode to be ECB. ECB no padding. Okay. So let's remove those dashes here. I guess that's the one which is bothering it. Ah, it says unable to decrypt. Okay, let's look at it here. So input, once the recipe is done, it's time to enter the encrypted beacon into the input area. Copy your encrypted string and paste it there. That's what we did. This is the key and this is the encrypted text, right? That's what is it? I'm not sure. Okay, let's copy this once again from here. Let's copy that. Bring this in here and then paste it back again. Is it due to these hyphens? What am I doing wrong? Is the key wrong? Oh no, it's not hex, it's UTF-8. Fine, sorry. Sorry. Rest all the stuff can be like that itself. Bake, that should have automatically done it. Let's just replace this because I tampered with the original text. Then put this back again. Anything? What else now? A B C D E F 1 2. That looks like, is it being reused once again? No, that's the exact key then. Okay. Did I copy anything wrong? So the decrypt the encrypted beacon with the key. This is the key which is there, and then this is the text what it sent me. That should have decrypted it anyway, but then it's not doing it. Let's paste it in here. No. Input raw. Okay, input is hex, output is hex, raw. What is this? 5. Base 64? No. UTF-8, okay. What else should I do? What else should I grab in? So operations, search for AES decrypt and drag it to the recipe area, which is the second panel, okay, which I did that. Then once the recipe is done, it's time to enter the encrypted beacon into the input area. Copy your encrypted string and paste it here. Output, once you have completed the above steps, you will need to click on the bake button to have auto bake, so I don't need that. So your encrypted string will decrypt using AES ECB decryption with the key provided, and the output will display the output area. Yeah, I know that, but then, come on, did I capture the right packet? I guess I did that right itself, but I don't know. Let's look at it again. Let's go back to that stream, which is this, and then let's look at some other traffic which is there because I'm not sure if that's the exact one which they're referring to because I saw another one traffic down. It could be the one I might be missing out something, or this tool might be giving itself a hard time. I don't know. Let's just refresh and see. Whatever happens, might will happen. Okay, nothing, nothing. Yeah, so we were here, and this is another post of the beacon. Yeah, it's here, no? So let's click on follow the HTTP stream. Yeah, this is the encrypted key. That's what I thought. I was missing something. Okay, so let's copy this and then put it in here. Now what's wrong? Oh yeah, we got it right now. So THM secret 101. Let's copy that. Okay, so that was it. That was it about the decryption of the beacon. So what's the beacon? That's given here. So this is what I was saying. I'm still alive, waiting for any instruction over, and the C2 server says, "Glad to hear that. Stand by for any further instructions." So that's how a beacon is going to be communicating with the C2 server. Again, if you're interested, you can just go through reading this. With this, let's just go to down because we got in the keys and we saw all the paths. Let's just see if there are any other traffics that we need to be looking at. Okay, so let's go back to IP stores and this. Where were we? Okay, it's taking us. We need to go down. Okay. Some HTTP communication, yes, beacon, and then do we see any other traffic? This says another beacon. Okay, so that's the behavior of a beacon. It's going to be sending in data in an irregular or a regular interval for it to say to the C2 server telling that it's alive. Okay, so that is it. You can, let's see the end. As Mixkitty opened the file with a click, she saw all the data. This wasn't a wasn't. The storm was brewing, much bigger to come. Mayor Malware's agent is far from done. Okay. This isn't just another breach, Mixkitty muttered to Bite. A grim realization drawing. We are going to need a bigger firewall. Okay, so tomorrow, is it about firewall? No, it's about reverse engineering. Fine. So, what is the first message? Let's go to the questions. So, what is the first message the payload sent to Mayor's C2 server? What is the first message? Okay. So, what is the first message? Are they referring to the first message or just to the beacon? Sent. What was the first message sent to the Mayor Malware C2 server? Okay. So I guess this is the first message. No, I don't think so. This is because it is not in the format of the answer. Let's click on the hint. Look at the post initial packet. Fine. Let's look at it there. So scrolling down, scrolling up. So post initial packet. Let's click on this. Let's follow the TCP stream. HTTP stream, yes. So what is the first message the payload sent to the malware C2 server? It was something. Oh, what is this format? I am in Mayor. Okay, I guess that's the message that they're expecting. Is it? Oh, yes. Okay, what is the IP address of the C2 server? The IP address of the C2 server, we can get it from here. So let's copy this and then put it in here. Then click on submit. Okay, that's good. What is the command sent by the C2 server to the target machine? It was who am I. Then what was the file name of the critical files exfiltrated by the C2 server? Credentials.txt. What secret message was sent back to the C2 server in an encrypted format through the beacon? So we got it here. Let's paste it in here. And then, yeah, come on, select it again. Copy. And then paste it in here. Click on submit. That's done. Learn more about Wireshark in our Wireshark traffic analysis room. Okay. So we completed day 20 of Advent of Cyber here. So it's about network traffic. It was about analyzing network traffics and looking at some beacons in the machine or in the traffic analysis. So that is it for today's video. Hope you did enjoy this video. If you did, hit on that like button. If you're new to this channel, hit on that subscribe button. So till then, till the next video is uploaded, stay smiling, stay happy. Bye bye. With